Okay. That's annoying. What could have caused that? Syntax, the answer is yes. What's your problem? I don't think I disconnect. So that's happened to me before. It's my microphone source in OBS. It just stops realizing that like like it stops listening to like the microphone. Like it just wasn't set. It's happened to me a couple times before, and I don't. Last time, like previously, there's been like updates or something that have caused it, but I don't know what caused it this time. Anyway, it's fixed now. Pebcac error. Problem something between chair and keyboard exists. Yeah. Typical. The data is the time it takes my professors or to grade my exam. Also known the time is at a maximum 30 days. So what kind of distribution should I consider? Ooh. Well, depends on the professor. Um yeah, basically, Jed. So if I was being naive, um, I would say, I guess it can't quite be a bell curve, but something like a bell curve. You know, centered at 15 days. The issue is that a bell curve goes off to infinity, and this would need to have a hard cutoff at 0 and 30. So you need to do like a little bit of adjustment there, and there's going to be a little judgment call with how you cut it off, but you can do that. You can also think about this again has an issue. It at least has a minimum of 0, but it doesn't have a maximum. But like an exponential distribution is worth considering too. This would be, I would maybe do 1 minus an exponential though. Because this is weighted towards it being a short wait time. You probably want to do the opposite. Or something like that. Or this, yeah. But like exponential curves or distributions are frequently used for like waiting times. The issue is that your professor is more likely to take longer rather than shorter. So that's what I would think. The Lowenheim-Skolem Theorem. Skolem sounds like a familiar name. Model theory? I don't know much about model theory. I have a Wikipedia page open in the background, though. Now I can hear you in stereo. Ooh. Is YouTube in stereo? Yeah, because I can also see it being some kind of bimodal thing, where like maybe if your professor sometimes has a lot of time, there's a good chance of it being early, but if it's not early, it's going to be late. So, I don't know. Oh, I see. Fair enough, Jed, yeah. Cardinality of sets in first order logic. Well, let's do the natural thing and go to Wikipedia and start reading. In mathematical logic, the Lowenheim-Skolem theorem is a theorem on the existence and cardinality of models. The precise formulation given below, it implies that if a countable first-order theory has an infinite model, then for every infinite cardinal number kappa, it has a model of size kappa. So that no first-order theory with an infinite model can have a unique model up to isomorphism. Okay, first question, what's a model? Relationship between formal theories and their models. Structures in which the statements of the theory hold. So you could make a theory about the real numbers, and the set of the real numbers would be the model, maybe? Or maybe it's even more fundamental than that, and the models are more like axioms. Do they have examples? All right. You and me both. Um, if a countable first order theory has an infinite model, for every infinite cardinal number kappa, it has a model of size kappa. I see a diagram here. Is this... It's probably going to be less understandable, but let's at least try to read this and see what it says. In its general form, the Lowenheim-Skolem Theorem states that for every signature sigma, every infinite sigma structure M, and infinite cardinal number... You know what? Maybe we should go to non-Wikipedia. Maybe we should not do that either. ELI 5. Ah, this is not ER... Oh, wait. Oh, it's Learn Math. Okay, that's what they meant. Essentially, partially characterized first-order logic in terms of what sort of statements and models can be described. There are several versions of the LS theorems. The modern variants differ significantly from the original theorems. For both theorems, suppose our logical system written in a first-order language of infinite cardinality lambda. I don't quite know what this means, but let's just go with it. Modern set theory is typically written in a first-order language of cardinality Aleph 0, natural numbers, I think. For all practical purposes, the LS theorems tell us that countable models are sufficient in modeling any set of first-order axioms. So the models are more like axioms than what I was saying before. So saying that using the Cantorian definition of countable and uncountable sets, the first order logic model is underdetermined. Whether an infinity within it is countable. There are sets satisfying those axioms? Okay, Arad. Thank you. So it's definitely talking about the countable and uncountable sets thing, energy that you were speaking of. This cardinality stuff is like a generalization of that. I believe countable is Aleph 0 and uncountable is Aleph 1. But there's also like Aleph 2, Aleph 3, and I think you can get even crazier stuff. But that is the basis for this like infinite cardinality stuff. Think like axioms of ZFC versus actual models were more familiar the axioms of a group theory rather than specific groups models. Okay, so thank you, Arad. So a specific group, like I don't know, reals under addition is a model, whereas the axioms of what a group must satisfy are a theory. Okay. Um, I'm trying to This sentence seems like a good thing to understand first. Countable models are sufficient in modeling any set of first-order axioms. I never remember what the first-order logic stuff actually means. For all x, if x is a human, then x is mortal. Okay. First order logic is, I think, what I'm probably used to seeing a lot of math things get written in. Leo, I never recommend Crash Course Model Theory video as a decent explanation of first order logic. Okay. Hey, Upamanyu. Sorry if I'm saying that wrong. So yeah, for those who are just jumping in, the question is from Energy to Hamter in chat, and it's basically, can you please explain the Lowenheim-Skolem theorems? And this is not something that I have existing knowledge about, so we're just trying to kind of fumble our way through it. Not really an expert in logic. My intuition for this is, if your language is finitary / countable, then you can only write countably many sentences to begin with. And an uncountable model must have wouldn't be accessible anyways. I don't know. That's better than what I can come up with so far, Rod. You joined college? Oh, nice. Upamanyu. Is this going to copy the correct address? Nope. I can just do this, though. Okay, so that's a crash course on model theory, which is probably a prerequisite to understanding this, but where Ramanuzan also went, ooh, sick. Hey, Suhas. It is countable because the statements are countable. First, second is on first order logic. Okay. Let's see what is up with this. If gamma is a set of satisfiable formulas in our language, then gamma is satisfiable in some model with cardinality less than or equal to lambda. What is our language? Is that English, or am I being stupid? Why not dark mode? I don't like dark mode, usually. It kind of hurts my eyes. Sorry that it... I'm sorry that's probably like burning your retinas, but I have the opposite problem. Flip my screen? Wait. I don't get it. For modern ZFC set theory, it's written in countable for dark? I don't know. I use AI, so I don't take this 100% certainty. At the same time, it's saying that a first order logic theory is any infinite model. A way to make statements true. Also, every single infinite size, including a minimum one that is countable. That doesn't seem far off, Energy, from the not understanding I have of this so far. Upwards / downward theorems also yield to a thing called Lefschetz theorem, which lets you replace your characteristic zero algebraically closed field with C. Whenever you're only working with first order. Huh. Lefschetz theories are so cheaty I hate them. Ooh, shots fired. Bimbly from tree to tree. Skirt, thank you so much for the 9 months. I am doo-doo, but so are you. Thank you again. Love shit spurt principle is so beautiful. You can use complex analysis. I was like, that did seem kind of interesting to me that just C kind of randomly pops out. No, you're good, Energy. I only feel bad that I don't have a very good answer for you. I wish I did. I'll keep on trying for a bit more though here. Especially because I haven't heard from Syntax yet anyway. For modern ZFC set theory, which is written in a countable first order language, this theorem implies that ZFC set theory can be satisfied by a countable model. It assumes that the ZFC axioms are consistent. The equation is actually known as Skolem's paradox. If ZFC set theory is a countable model, the same countable model must satisfy the sentence there are uncountably many sets. Very puzzling model itself only has countably many elements, hence countably many sets. There are uncountably many sets. Well, not quite. What the model really says is there is no function in this model which puts n into one-to-one correspondence with all of the sets. Yeah, I'm kind of lost here. I can understand this, that you don't need infinitely many. Well, I don't know. I'm saying the wrong thing already. I don't know. I'm okay with it being in like set theory, keep it from algebraic geometry for Lefschetz theorem. C pops out specifically because it is a unique characteristic zero field of size R. Huh. Does C have the same cardinality as R? Even though it's like, it seems more like R2. Does R2 have the same cardinality as R? I don't know how you even think about that. They all do. Wow, that's weird. This being characteristic 0 isn't a first order statement. It is counting many first order statements. That is how you get the positive characteristic tricks. Yeah, I don't know what the characteristic part means, but it's fair enough. You need the first order to crash. Yeah, that's fair enough, Leo. C equals R2 equals R. I kind of don't like that, but I can go with it. How do you... I assume that means that there's a map from R to R2. That's 1-to-1 and onto, right? Okay, maybe I shouldn't go down this road. If A and B are infinite, oh, the Cartesian product A times B, the cardinality of that is equal to the maximum of A and B. The cardinalities, okay. Watch it on stream? Okay. I don't like watching more than a short video on stream usually, but thank you for letting me know. Oh, space filling curves. I was reading about those like a few weeks ago, I think. So someone asked about it, but I never learned about them. Hey, smart stream. Yeah, you know how I feel about watching your content, Leo. Like, unless I'm being threatened, I'm just not gonna do it. I'm still not sure. My understanding is that this is saying if a first order logic is capable of expressing an infinite set, then it can't restrict the sets it expresses to being countable. She kind of like being waterboarded. That's not true, but it is fun to joke about. It can't restrict the sets it expresses to being countable, or it can restrict the sets it expresses to being uncountable. That seems correct, Energy? You won't install waterboarding anymore? um, yeah, um, I don't know. I have a hard time saying definitely yes or definitely no, but that's consistent with like what I've learned so far just from like Arad and Leo. Smart stream. I made a simulation on motion physics. Can I send you the link so you can check it out and give me some feedback? Unfortunately, there's not a good way to send a link over YouTube Smart stream. It just will always get eaten. I'm sorry. Okay. Sounds good. Energy. Thank you for trying with me. Okay, so um syntax asked kind of a half meaning question earlier about statistics, but I'm still waiting to hear back. So we'll just go to our default linear algebra stuff until we get a question. Said ketchup, left maths too long ago, how to restart. Uh Basically expect that you're gonna have forgotten a lot of stuff and try not to get too discouraged. Ketchup. It's really rough when you're first starting out, but it does come back quicker than the first time you learned it. Um and yeah, depending on like what level of math you're coming back to, I can recommend a few different resources. Um where is it? If you want to learn stuff that's like before university level math, oops, OpenStax is a good free resource. Um, and even if these are just like free textbooks, and even if you're not a fan of textbooks in particular, that what it is super nice for is just like benchmarking yourself to figure out what you do and don't know, because it just follows like a very typical like math curriculum. So it's a good thing to know like what's out there and what you should be learning approximately when. If you're talking about university level math, I would say open textbook library. Again, free in legal textbooks that are used in actual like universities. Yeah, Discord works. Smart stream. Came back to math after doing almost none for at least 2 years and doing very little for another 2 years, making terrible content Don would never watch for 1 year. Yeah, so I graduated my bachelor's in 2018. I was a tutor not long after I graduated for, I don't know, like 6 to 9 months ish. And then after that, I didn't do math for like 4 years. And then I only started to do math again when I started the stream like 3.5 years ago now. I think you said ketchup for remembering to do that. I'm 21. Yep, I'm 21. 21. Okay. Looks like they posted it. Let me open her up. Ooh. Okay, I was making sure this wasn't like a bait link or something like that. Uh, this looks sick though. You're a 10th grade student and you made this smart stream? This is really impressive. I mean, if it is all AI, that's a lot less impressive. um, yeah, I was just like looking at the header anyway. I don't know why this makes me laugh. Ooh, I like the traces for why this looks like nice for like why periodic motion is related to sines and cosines. Ooh, we got a little space background here. Nice. Smart Stream. This is a really like clean website. Time warp. I didn't even see that. Let's go warp speed. I assume that's just like a. This is like 4 times speed. Well, actually, the area swept is it's gotten bigger. Maybe something more is happening. M equals GM. I don't know what that would mean. I guess it's something to do with mass. Ooh. It's like it's changing its mind for how it wants to orbit. Nope, just gonna come over here. No, 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 no. Just gonna come back over here. Okay. Anyway. Smart stream, well done. I hope it wasn't like all AI and was at least partially you, but that is a very nice website. Can you sling it out far enough that it loses? I think that might have been what I just did before. Let's. Oh, I guess if you do that, well, I think it's still a little bit. If it goes far enough, it just seems like it resets. That's okay. I kind of did a sling there. It only goes down to 0.35, not quite 0. Simulation based on gravity. Yeah, sure, smart stream. Prove that if A has at least 2 elements and A times A slash sim A. What is slash sim again? Then power set A times power set A slash sim P of A, where P is the power set. Interesting. So, shoot, I'm sorry, Socknow, did I say hi to you, or did I just say hi in my head? I meant to say hi. I don't know if I said that out loud. But Socknow, hi. It's been a minute. You're still trying to find work? I hope that you find it. I hope that things are going as well for you as they can. You got the data. It's surprising that max 30. Forget it. Teachers did not care. The mean take double pendulum simulation Desmos getting mogged by a 10th grader. Yeah, feel free to drop it or to drop the data syntax. Besides, I did see that R2 equals R. Yeah, I guess I can see how that would build into a bunny. What if massless things actually went curved? Equinumerous or by... Oh, okay. Thank you, bunny. I mean, in curved space-time, Arad. Guard doesn't affect me. Kind of cool, but really inconvenient. You sent it? Okay. Then after this, we'll look at syntaxes. Data. Ooh. That's fun. I would really love to learn some astrophysics. Mercury. Woo! 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 Is that a comet? What are you? Oh, that's the moon. The sun stole our moon. Go through the left objects. Oh, you can place star. Ooh. Wait, did the sun absorb that other star? What a jerk. Oh, it's just absorbing it. That's cool. Yeah, it's like Beyblades. How long did it take to build this bunny ass? I guess that's for smart stream. Data in days from last year exams. 14-1. Ooh. Well, certainly towards the higher end, but yeah, like I thought, it's kind of bimodal. Or less, I would think it'd be kind of bimodal. Kerbal Space Program? I've been recommended it before. I probably would enjoy it. I don't know. Oh wait, there's a, okay. Let me open it back up. If there's a black hole, we got to play with that. I do want to. There it is. Just ate it. Okay, I just destroyed. I guess not the universe, but the solar system. Okay. You dated a girl that was like that, like woo, like that. Like, I mean, that's true, Leo. You can quote me on that. Last night, I was having the Factorio itch. I kind of want to. I probably would start up a fresh save if I went back to Factorio. But I'm not gonna lie when I said I kind of wanted to do it. You two, except the Factorio part. You just had an itch. Sorry, guys. I feel like I've been doing a bad job of keeping up with chat. If I miss someone's message, just know that I appreciate you typing that. So the histogram is something like that of this data syntax. And the reason behind the Big Bang, yep. TS Mentizen. We're kind of messing around. The stream in general is you can ask math questions to me and I'll do my best to answer them. Thank you, Leo. And so right now it's kind of a meme question from Syntax Error about when his next exam is going to get graded. If we can guess that based off the professor's previous time to grade exams. And so I just made like a quick eyeball histogram of like this data here for the number of days that it took to grade. We forgot that about the one day, but that was a blessing. Teachers locked in. Yeah. Oh, there you go. Just get Leo to grade it. This is 75% off sale on KSP. I mean, I don't know if I would actually play KSP, but it is something I should probably like keep in mind. A+, congrats. Hey, there you go, Syntax. Perfect. My standards of entertainment are subterranean. Hey, you know, life is more fun when you're stupid, okay, Arad? I enjoy being entertained by the simple things in life. And also, that was clearly about space. There's nothing subterranean about space. If anything, it's extraterranean. Collegiate classic grades and putting in S as an achievable, really hard to get grade. There you go. This might have been your worst uni performance thus far. Which class was this for again? My wisdom goes deep. Number theory 2. Okay. That sounds difficult. Pleasure can be supported by an illusion, but happiness rests upon truth. Ooh. That's a great fortune. You love the material though? That's good. Number theory is so great they made a sequel. Suck now. I was interrupted by another interviewer like it's Chatterbox Central, but no bite with employers. Like it's just crazy. Huh. Yes, suck now. Good luck. I'm right there with you in applying to jobs. And I can't get crap for a response. So TT360. Hello. What'd they do in number theory 2? They took away the numbers. That was the big twist. The new bad guy wasn't as cool as the original. Kind of crazy. A lot of it is about second degree polynomials mod P. Really? But yeah, I do think something you can do with an exponential curve here, or exponential distribution, not curve. Happiness rests upon truth. Does that mean a happy meal is an oxymoron? Because that's not a meal. Mod D's nuts. Hey, Boston. Always a classic. About nuts? I know all about nuts. It's like when numbers can be represented the sum of two squares falls neatly from there. Oh, sure. That is a second order polynomial, isn't it? Fair enough. No, two squares a lot of times though. Oh, this is where we're getting back into the freaking unit distance conjecture, right? Coconut is not a nut. It's the cocoa fruit from the cocoa tree in the cocoa palm family. Yeah. I feel like you're. This is from a song that I'm not recognizing. The palace. Is it like put the lime in the coconut? Is it that song? All right. Well, let's see, Jed. Oop. The coconut song. That's actually okay. Let's not play music in the background. That's smart, right? Oh wait, we've watched this before. I remember it now. I'll just watch the first like minute or something. Yeah, sorry, Leo. It's because of copyright. This is what Jed was quoting. There we go. What's a generation work of art? Exactly. Yeah. I mean, it's not that it's different on Twitch. It's that in Twitch there's a way to play audio live, but not have it saved in the recording. So it's more like you just don't get caught. Friend starting uni at the same campus, starting physics, might crash one of his lectures. Oh yeah, that'd be cool syntax. Okay, if someone has a question, feel free to ask it. I think we'll try to speed run section 1B about vector spaces, if not. Just repeating the properties of a field. Find a vector space to be set V with an addition and a scalar multiplication on V that satisfies properties in the paragraph above. Addition on a set V is a function assigns an element U plus V and V to each pair of elements U, comma V and V. A scalar multiplication on a set V is a function that assigns an element lambda V and V to each lambda and F and each V and V. Yep. Formal definition of a vector space. A vector space V is a set along with an addition V and scalar multiplication on V. The following properties hold. Commutative, associative, additive identity, additive inverse, multiplicative identity, and distributive. Got some farting? Oh, yep. I know how that goes. Considering going to philosophy, literature, or art stuff lecture or two just to see what they do, you think it's allowed even if you don't take the course? Yeah, I mean, if they don't, like, so I was at the university that I just went to, there's, I don't know why, but like, professors aren't allowed to take attendance even if they wanted to. And you can just kind of like show up to a classroom and listen in if you wanted to. I think most professors wouldn't care enough to really ask if you're actually registered for the class. And there's definitely one time in my calculus and variations class that like the class size suddenly doubled because everyone was interested in hearing that particular lecture that day for some reason. It was about Hamilton-Jacobi equation, or I think that's what it's called. It's like the PDE that you solve to find the optimizing function. Most vector space are called vectors or points. Vector space over R is a real vector space. Vector space over C is called a complex vector space. Simplest vector space is vector space 0, which contains only one point. F infinity. Sure. Bit too sick. When I was in Paris, he wanted to go see a lecture or two. You think lecture just open to the public? That's sick. Well, you were also sick. That is also sick. That would be cool to do, like in your retirement. Just show up to lectures and follow along with classes. Your responses is because I have been doing cover letters with each job on Indeed. Also been trying to find their website off Indeed, sign up with them. I can walk to an employer that hasn't responded, show my face. I don't have it formatted. That they don't allow visitation. Oh, nice. Well, it sounds like you're doing everything you can, Sock. Now, I hope it pans out for you soon. You're on painkillers and beer that whole trip, so you could at least enjoy your time. Oh God, I don't know if you're supposed to mix those two things, but I guess you're still here, so it worked out. Okay, I guarantee you I'm gonna forget about this notation and I'm gonna see like FR or something and gonna be very confused about what it means, but FS denotes the set of functions from S to F. Not healthy, it was like four days, so who cares? Just wait until you're older. For FG and FS, the sum F plus G. What's the difference between a set of functions and a space of functions? Is there a difference, or do we just like fancy new words? Employers have issues communicating, like you need to communicate every possible way for them to see you? Yeah. Yeah. Space usually has structure. You may see the terms mean the same thing. Okay. Say that again? Oh, the thing I just said was like, what's the difference between a set of functions and a space of functions? I don't know if you meant the last thing I said to you, syntax. This particular set of functions is in fact a vector space. Are they saying that? The codomain space is a field, then all functions that map into the codomain define a vector space. Oh god. The codomain space is a field. Right, that's where it maps to. In this case, F. Then all functions that map into that codomain define a vector space. Okay. All functions from some particular domain, yes. Okay. Kartik, feel free to ask it. Summon scalar multiplication. I guess so. It's all about the base. No treble. Example notation above, if S is the interval 0, 1 and F equals R, then R01 is a set of real valued functions on the interval 0, 1. Now that phrasing is very misleading to me. 0, 1 is the domain. R is the range, to put in my simpleton, like pleb math terms. This is where we learn that Fs is a vector space. Okay. If it's a non-empty set, then Fs, with the operations of addition, scalar multiplication defined above, is a vector space over F. The additive identity is the 0 function. 0 of x. It's a great function. For F and Fs, the additive inverse of the function F is the function minus F. Sure. You also need to get rid of AI algorithms. Like you should opt out of AI filtering when I see them because they're so micromanaged by that algorithm. Doesn't leave reasonable room for difference, and employers know this. Yeah, I get that they do have just like a stupid amount of applications to sort through. TS Mentism, what do I do for a living? I apply to jobs for a living, although I'm not paid for it. I'm not employed. Me looking for the 0 function to describe how much my next video Dawn is watching. Yep. You also need some throat medicine. You need to go to a pharmacy. The clerk didn't know English for throat. She pointed at her head, went hurt here. Need to point at my throat and fake cough and go hurt here. That's funny. Like the charades that you have to do to communicate. This is wrong because it needs to be non-empty. Oh, for not having any cardinality constraints? Okay. Maps out of the empty set form a zero-dimensional vector space. No. Can you map the empty set to something? Does that make sense as a function? Empty to R has one element. It will be a singleton. I guess you can do that. That's very weird. It's a function you're not allowed to plug anything into. I feel like that's just a constant. So it's the empty set. Now the function from a singleton to 0, which I think is what you need for that. Cut off me tablets or syrup. Per accident was too much for me. I couldn't quite understand what syrup meant. It's like whatever is cheaper. I'm in grade 9 and got 30 out of 9 in math. I assume 30 out of 90? If you got 30 out of 9, that sounds like you're already pretty good. Yeah, T.S. Mentyson. Math just kind of comes down to a lot of practice, unfortunately. All you can do is just keep working on problems. It does commute with F, A, disjoint union B, and currying. Currying? This construction, I don't think it works. With the empty set as a domain, I might be wrong. I don't know. So along with Paris, I would love to go one day. Set of functions from a set into a field always forms a vector space. Yes, I think that's what we just learned here. Oh, also, is driveling liar here? Paging driveling liar, if you are here. More question is, if we made it work this way, would the theory work well, rather than does it work? I guess so. For your first two checks, seems like FMT equals 0 works well. Okay. The vector space Fn is a special case of vector space Fs, because each vector in Fn can be thought of as a function x from the set 1 to n to f. Oh. I never thought about that. Actually, I think I have thought about that. Now that I think about it. That's a really stupid way to phrase something. I guess so. That takes some getting used to. Also works well with tensor products versus currying. I don't know what currying is. You can proceed to the next line. Did the textbook say no to the empty set? I don't think so. I don't think we've mentioned the empty set much, to be honest. Oh, this is Kartik's problem. Okay, let's see what's up with Kartik's problem here. No, I clicked the wrong thing. Ugh. Ah. Oh no, I'm clicking all the wrong buttons right now. Aleph Mew, thank you so much for the raid. How was your stream? What were you up to? I have been slacking. I've been following you for ages, and I have not said hi in your stream, and I'm sorry about that. Did I do my math homework? I don't have any homework now, thank God. Thank you for the raid. People, please check out Aleph Mew, fellow math streamer. For those of you who are new to my stream, my name is Don. I just recently earned a master's in applied math. The theme of the stream is you can ask me any math question you want. I'll do my best to answer it. If there aren't questions from chat, I'll do some sort of studying. We just got this question from Kartik in the YouTube chat, and I'm just about to read through it now. Okay, God, I finally got it all. Hello, Aleph. And Tyler Null Plus. Hello? The map from the empty set is just an empty set. Apparently it can be a singleton. I don't know. The map from upset is like me, upset. Okay, so an AI checks retinal scans for a rare disease, correctly detects a disease 98% of the time when it is actually present. What's upset? Also doing some math, some algebra review, some partial fraction. Oh, nice. That it's annoying how important partial fraction decomposition is. I wish it wasn't important because it could take a long time. The set of maps from the empty set is a singleton, which contains the empty set only. Oh, okay. However, it also gives a false positive to 4% of healthy people. The disease is very rare, affecting only about 1 in 500 people. If you test positive during general hospital screening, what probability you actually have the disease? Mention the same AI is used only in patients referred by a specialist, where about 1 in 5 patients actually have the disease. If you test positive in this higher risk group, what is the probability you truly have the disease? Okay, so this is like a conditional probability question. Whip out the Bayes theorem. Whip it out. Is this the Bayes theorem or I'm rusty on my probability. What's your Bayes theorem? If you test positive during a general hospital screening, what is the probability you actually have the disease? Okay, so we want probability you test positive. Probability you test positive given you have the disease. Yeah, Aleph, thank you again. Okay, we're seeing a lot of calls for Bayes' theorem. Well, let me bring that in here. Yeah. Wait, where's my screenshot? No worries. I appreciate the follow. You think I wrote the opposite? If you test positive during a general hospital screening, what's probably you actually have the disease? Oh, crap. Thank you. I think you're right. Probably you do have the disease given you test positive. You like the way I move my Bayes theorem, Leo? Do we use it for this first part of the question too? It has a false positive. I guess so. Thank you, Leo. Just do 7 tests. There you go. Isn't there like a counterintuitive thing where like doing more tests doesn't always increase your certainty or something like that? Times probability. Yeah, there's like some weird thing. Just prompt it to not make mistakes. All right, can we find all these probabilities in the question? The true answer to this question is just asking ChatGPT. Salve-Riemann hypothesis, no mistake. This approach to test certainty itself? Okay. Adaptations in your probability. It's called the Poisson distribution. Yeah, probability is really cool. I'm just I feel like when it comes to probability, my knowledge of it is like a jigsaw puzzle that's missing like half the pieces. Certain things I remember well, certain things I just don't. GLLRC? Never heard about it. Okay, so probably that you test positive given you have the disease. So is that our 0.98? Correctly detects it 90% of the time when when it is actually present. So that's the given you have the disease. Okay. Well, wait. Probably you test positive given. Okay, yeah, so that's 0.98. Probably you have the disease is 1 in 500. Mixing fraction and decimals, my favorite. Okay, and then the probability that you test positive. Well, you could, I guess we need to deal with different cases here. So you could have a true positive or you could have a false positive, and we need to account for both of those situations. So if you're healthy, you're in 499 out of 500. So it's like well, I guess let's write it down here. 0.04 times 499 over 500 plus 0.98 times 1 in 500? I think. Did I try to turn it on and off again? Pure mathematician forced to live in a world of applied mathematicians. You're not getting a job. uh, right, this is a two-part question. I'm still trying to work through the first part. It says positive because your great attitude. Hell yeah, Leo. All right, let's plug that baby into Wolfram Alpha and see what pops out. You know, please feel free to go take care of yourself too. It's always exhausting to do a whole stream and then feel like you have to hang out somewhere else too. Times 1 in 500 divided by 0.04 times 499 in 500 plus 0.98 times 1 in 500. Bam. 047. I guess we can call that 047. Sounds good. Aleph, thank you again. And hopefully I catch you soon too. Yo. Most people would have to now do this arithmetic. Couldn't imagine worse torture. Oh god, yeah, to actually have to solve that. You can cancel the 500 off the bat, but you still have a lot of annoying math to do there. Is Leon short for Napoleon? I thought you guys are short already. Okay, I think I have an answer for the first part. What's the second part? Imagine the same AI is used only on patients referred by a specialist, or about 1 in 5 patients actually have the disease. You test positive in this higher risk group. Probably you truly have the disease. Why it's so different from the first situation. So is this the same thing, except we change the 1 in 500 to 1 in 5? I think that's all it takes here. Let's see what that gives us. Wolfram Alpha, away. Let's do it in a new tab. $86, or yeah, 86. .98 times 1 in 5 over 0.04 times 4 in 5 plus 0.98 times 1 in 5. It's about 0.86. So why is it so different from the first situation? I'm right? Hell yeah. Thank you. Now that Russell Westbrook is retiring, they're going to try to make the league. I don't know who Russell Westbrook is. Russell Westbrook. Since all because the problem doesn't explicitly say that the test and expert tests are independent events. I guess if you're more likely to have it in the first place, you get less false positives, question mark? Less false negatives or something like that? I don't know. Let me read what syntax put earlier about the previous thing. We say f of x equals y, if and only if x, y. Pretty much less false positives by a lot? Okay. In f, where f is a subset of the Cartesian product of the domain, the empty set, and the range. Let me, I guess, put this on screen as I'm reading it. An example really does happen all the time, with even more extreme numbers. Interesting. F is a subset of the Cartesian product of the domain, the empty set, and the range. Okay, sure. But the Cartesian product of the empty set with anything is the empty set. It's like a black hole, it just eats the other set. Therefore, F is the empty set. Also, for F to be a map, we must have that for X in the domain. There is precisely one thing in the range that doesn't really matter, as there's nothing in the domain. This makes sense. I like this. All right, we use Bayes' theorem. Ivan would be proud. I do have this E&M book open. I don't think I'm going to do E&M today, though. Answer this question, then. Okay. What is the truth value of the following? For all x and empty, 1 plus 1 equals 0. Is this vacuously true? That's what my gut is telling me. Let's think about it more. For all x in empty, 1 plus 1 equals 0. Yeah, I think it's vacuously true. Remaps from any set forming a singleton in the book notation, you can also see it like f0 equals 1. Is that the cardinality of f0? Or is it literally f0? Because saying just a field, well, maybe you're enumerating the entire set. Or wait, this maps the empty set to a field. I assume this is cardinality. Am I talking about that racing game? Oh, F0, F1? Or F0, yeah. What about for all x? In general, if A has cardinality n and B has cardinality m, then the set of functions. Hey, Ariane. From B to A has cardinality n to the m. Oh, okay, Ultra. Cardinality of A to B is B to the A. Yeah, I'm still kind of saying this doesn't quite make sense to me because we're still chopping off the absolute value bars, aren't we? Denoted as caret BA? Ew. Oh, like, oh, it's like a, ew. No, I hate that. But I guess that kind of makes sense. But what does this equal sign mean? It's an equality of sets. I don't know. Because one is the set. Huh. That's where I think Leah was going with this question here. You don't use von Neumann ordinals, so it is wrong. What about for all x in this, 1 plus 1 equals 1? I think that's true. I think there's a definition of addition such that this is true. It's like addition mod 1 or something. Weird. Von Neumann ordinals are goated. We have /n equal less than. Are those the ordinals? Probably. Over the naturals? Yeah, I think this is true. I just thought it was catchy, Ariane. My name used to be Don Does Math, and then I found out that there's another streamer on Twitch who came before me, and her name is Cat Does Maths. And I feel like I was copying her. And so for that, among other reasons, I just tried to come up with a different name. Really addicted to Factorio. I've been kind of having the itch. Is that a great story? I'll take it, but like a pretty like plain story to me. Exercise for chat. Thank God I get to dodge this one. Come up with an alternate construction for ordinals where less than is still in. But that is not the same as von Neumann ordinals. Work on it then? Okay, I'll try to make up a story where I fought a dragon. Hey, Lucas. Comes to the vector space R01 are real valued functions on 01, not lists. In general, a vector space is an abstract entity whose elements might be lists, functions, or weird objects, like me. You can do something that's basically the same thing. Ultra has it? Okay. That's true. Donkey did have kids with a dragon, which they kind of gloss over how weird that is. Soon we'll see further things of vector spaces. We need to develop some of the elementary properties of vector spaces. We can prove that it's unique. Suppose 0 and 0 prime, like Optimus Prime, are both additive identities. Then 0 prime is equal to 0 prime plus 0, which is equal to 0 plus 0 prime, which is equal to 0. Sure. So commutativity implies a unique additive identity, I guess. Is what they're saying. Found some your local library has some math books. Hell yeah. Some stupid ass small library. Dude, a nice library is really nice. If that wasn't obvious. Especially in summer when it's on hot days, I just go and walk over to the library and I hang out there during the hottest part of the day. You think monomic construction is fine, you just don't use it. Okay. No library is slightly nice. 1,200 square meters? Wow. Going to the library like it's a sweat lodge? No, I go for I go to steal their AC. I don't have AC in my apartment. My apartment gets miserable too. Like it I have a thermometer in here and it gets hotter inside than it does outdoors. And so when it's already like 90 outside, it's I just can't exist inside here. I let the bear get hot on its own. Yeah. That poor bear. I go learn here. You go just steal their AC. That's the kind of person I am, Lucas. Yep. I'm just pretending to learn. Now what I do, I turn on the VPN and I apply to jobs. That's what I've been doing there. Each element V in a vector space has an additive inverse. Element W in the vector space such that V plus W equals 0. Next result shows each element in a vector space has only one additive inverse. Do the same thing. Suppose you have a W and a W prime. W is equal to W plus 0. Okay, yeah. That's nothing revolutionary. Again, I guess we use associativity and commutativity now. Volunteered for a bit in my local library, relatively small town. Turned out we didn't have many math books, but a disproportionate amount of material on mind reading ESP stuff. I've stumbled into that section of the library before. That's like the conspiracy section, like conspiracy theory section. And it's kind of fun just to see what theories are out there. There was a fair amount of stuff about Atlantis. I forget what else was there. That's how a rod does it. First to say that I learned how an AC works. Just the ambiguous safe in the cold. Wow, that's a. It's like saying I know how planes work because I've flown before. I have to watch people walk backwards poorly. I almost fall over, never quite full tumble, just lots of off balance. What? Is there like a walking backwards race? Whatever you're doing, enjoy, Leo. How does AC work, Boston? How does it work then? It flies. It works well. Called a hobby? I should try getting one. You're right. All right, see ya, Aryam. Thank you for hanging out. Because additive inverses are unique, the following notation now makes sense. Minus V is the additive inverse of V. W minus V is now defined to be W plus minus V. Sure. For the rest of this book, V denotes a vector space over F. Apparently I have a couple of uni books, even though my city doesn't even have a uni. Ooh, that's good though. It is a W. The next result, 0 denotes a scalar on the left side of the equation and a vector on the right side. Scalar 0 times vector V is equal to vector 0 for every V in V. Wait. What is this? Adding the additive inverse of 0V to both sides of the equation above gives 0 equals 0V. Oh my god. Okay, sure. That I feel like they shouldn't have to prove that, but okay. The reverse heat pump with a fan. Well, how does the heat pump work? It's like Wikipedia. I can always keep asking like how or why. Vapor compression cycle. Kubak? Quack quack. This is a linear algebra textbook, so I guess like university. Someone has to prove it. I guess so. ADK, if it's me, now I'm better at math, the magic of the world loses power by a little bit. Really? I think the world gets more magical the more math and physics I've learned. It's like you know the reason why things happen. And that's really cool. What even is a force? I mean, it's really a thing that's really good for making predictions. It doesn't like it's a theory that just happens to work really well. I don't think it actually exists in the universe. As like a particle or something. Well, actually, that's not true. I'm thinking of like the packets of force. You know what? I shouldn't talk about things I don't know about. There are actual like on like the quantum level, that doesn't force get sent out in little like packets? I don't know. I at least, how about this? As like Newton, for with what Newton would have known, it's just a part of a theory. I think. But again, I'm kind of out of my depth here. You think that's really good at making predictions, Luke? True. Force is like how much an object wants to potentially move. Basically, yeah. It's equal to mass times acceleration. So whatever gets you there. Physics is weird. Math is way easier. I think they're both incredibly difficult, and they're both incredibly weird. It's for their own unique reasons. The result in 1.30 involves the additive identity of V in scalar multiplication. The only part of the definition of vector space that connects vector addition and multiplication is a distributive property. Thus, it must be used in the proof of 1.30. Fair enough. I guess that's why they had such a weird proof. Next rule, 0 denotes the additive identity of V. Although the proofs are similar, 1.30 and 1.31 are not identical. More precisely, 1.30 states the product scalar of the 0 and any vector equals the vector 0, whereas 1.31 states that the product of any scalar and the vector 0 equals... Okay, sure. And we're proving this basically the same way? Yep. Okay. Great proof. I love it. Oh, hey, we're almost at the exercises. Yay. We show if an element of V is multiplied by the scalar -1, the result is the additive inverse of the element of V. God, I hate this. The number -1 times a vector. -1 times V is equal to -V for every V in V. For V in V, we have V plus -1 times V is equal to 1V plus -1V. Use distributive property to get 0 times V, and that's just 0. Okay. We had a lecture at the end of high school featuring modern physics. There was no math, but our teacher lectured forces are carried by bosons, no mass, no charge, or anything like you said, packets of energy. Yeah, I don't know what I'm talking about with that, Kuwak. So there might be evidence that forces actually exists in the universe. I couldn't tell you. Oh yeah, no, I thought it was funny to read it the way that you wrote it. All right, let's prove if minus V is equal to V. Any bets on whether that's true? Well, I guess they tell us that it is true, and of course it's going to be true. All right, let's do something weird. Let's do like minus V is equal to minus 1V is equal to minus, it's a weird equal sign, 0 minus 1V. What am I doing? I guess is equal to minus 0V minus 1V. Now we use the distributive property? Because we can say this scalar -1 times this scalar -1 is +1. I think that's okay. That we don't you don't have to do any proofs. I mean, I what I just wrote kind of disgusts me, and I don't like it. But it is important to be able to do this, I think. So that's why I'm doing this problem. You've proven that minus minus one is one in a field. God damn it. I guess not ultra products. But I mean, okay. I think it's basically the same idea though, right? Like if I want to be even more careful, I can avoid using actual subtraction here. Oh wait, no. Uh I was about to use the fact that I wanted to prove. Is it that minus minus one is equal to minus one times minus one? Are we finally allowed to say that that's equal to one? Maybe I need to look at the properties of a field again. I don't know. I don't know if I can prove that minus one is one. Multiplicative inverse? Okay, we know that minus one has a multiplicative inverse. We just need to show that it's minus one. Okay. Could actually in linear algebra. Yeah, it's something like that. Kulak. It's just like we're starting out super like fundamental. Leo, I'm bored. Can you say something really funny, please, please, please? Penis. An alien smoking? Sure. Show minus minus v equals v in a group. Uh, I don't know. Can I? Uh, there exists a number beta such that minus one times beta is equal to one. We know that's true. We just need to find what beta is. Can we suppose it's not minus one? And show a contradiction? Hmm. Okay, so we know. Oh, wait. I see. Oh, never mind. I mean, what I was going to say is we can multiply each side by minus one. But then again, I'm supposing that minus one times minus one is one. God, I hate doing this. Uh. We want to look for something involving the distributive property. Should I say that beta is equal to 0 plus beta? Hmm. Use that last proposition from 1b. Wait. Like, oh. Oh. Well, yeah. Well, yeah, okay, so this isn't related to like the -1 times -1 equals 1 thing. Ultra, I think I do need a hint. But I guess was I using that? No, I think I did use that proposition when I said this. How does minus minus v relate to minus v? It's the additive inverse of minus v? Unique additive inverse. So I don't know. We know there's an element like see. Okay. We know this is true. That's what we're saying, and we can factor -1 out. Like, you don't have to use -1 at all? Oh, it's the uniqueness. Okay. Okay, thank you. Are unique, and minus v is... Ugh. Too much writing. The additive inverse of v, then minus v equals v. Ugh. Disgusting. Just use the theorem again. Minus v is the additive inverse of minus v by definition, but so is v. Yes. Hope you're doing well, Dr. Cook. When Zach was doing the E&M test today, I was following along, and I did the multiple choice at least. I didn't have time to do the free response, but those questions were really good. All right, let me pull in the next problem. Does the same thing go? Wait, so I'm coming back down to what Ultra Product said about proving -1 times -1 is 1. Um, can we do the same thing with uniqueness? Well, no, I don't know. Oh, you missed it? Normally he publishes his VODs like maybe a few days after he streams. So hopefully it'll be up at some point. Hey, I'm stuttering. Hey, Barat. If there's one thing you think is so interesting, everybody should know about it, what should it be? Not a lot of people know about it, though. Oh, that's a good question. Hmm. These nuts. There's a lot of things that I really love, but like the general public wouldn't like appreciate it if you just like dropped it on someone who doesn't have some prerequisite knowledge. I I guess I would say like I do really love how special relativity implies the existence of magnetic fields. Like the connection there, I think, is really mind blowing. So, and that's something that I think people could understand at least like conceptually with enough explanation. It does. It's really cool. Um, when I was doing this reading with Fenlox fan, uh, that's basically what chapter 5 was all about, explaining why that's true. And I was like, reading that chapter was like reading a novel to me. It was like, it was just really exciting. I had this book up because I was kind of tempted to finish Dr. Cook's exam. I didn't do the free response part, but I don't know. I also wanted to do linear algebra. And Max, I see what you said. Um, I'll read that in a second. Computability theory, equivalence of Turing machines programs is undecidable. Oh, that's a cool one too. Axler is really good and motivates you to go through it. Honestly, there's been a fair amount of hate on Axler from people in chat, but I just wanted to learn linear algebra a little more abstractly than I've learned it before. Uh, I'm not particularly going through it quickly. I've only looked at it on stream and not a little bit off stream, so I don't know. Linear algebra is just like a beautiful topic, and I want to know it better for stuff like machine learning and also just in general. But yeah, so I say I'm pretty good at like the introductory linear algebra stuff, but as soon as it gets even slightly abstract, I tend to like drop off. So if almost 1 = 2, then your clock rotates. Like real life books way more than online books. Yeah, I'd rather have a physical book too, but that's really expensive. It's not really cool. I can't picture the accent special relativity with electromagnetism. It's basically what Einstein's 1905-ish paper was about when he first wrote about special relativity. Okay, let me read what Max said. Can you show that for all A, B, and K, which is a field, for all V and V, knowing why it's called special relativity? I mean, that's something. Okay, so is this basically like associativity for scalar multiplication, I guess? And we probably want to do, is it the same like weird distributivity thing? Like I would want to say that A times BV, alcohol by volume, equal to A times 0 plus B V? And we're allowed to distribute the A inside of here? That's what I would think, Max. Thorfinn, hello? Oh, wait, this is part of the definition of a vector space, at least in this book. Partial recursive function, the best notion we have for algorithm is interesting. Basically, in the late 1800s and early 1900s, people were trying to figure out what an algorithm is. Gödel came up with partial recursive functions, which is still the best notion we have. But later, Turing found an equivalent notion that is in some ways nicer to work with, ended up being useful in making computers because it's very close to how computers work. Every decent notion created since, like almost all programming languages, are equivalent to partial recursive functions and Turing machines. Yeah, I think notion is just a general, like, it's not like a math term here. It's just like an idea. Some programming languages like Agda are strictly weaker in that they can't compute some things. Two machines are simple models of computation and come to computers slash GPUs with finite memory. Easier to proof with scalar simpler and do less in each computation step. Computers have changed how fast you can do some computations, but not which ones can be done. Interesting. Voices cracking. I mean, I don't. Maybe I could use some water. Yeah, it's like theoretical computer science type of stuff, Lucas. I don't know much about it myself. Finite time can mean very different amounts of time, very different looking algorithms. I think truthfully there's not best notion for an algorithm because it is so dependent on your physical device computing. Okay. Orphan, yeah, this is a linear algebra textbook called Linear Algebra Done Right. Polylog factor equivalent to actual practical algorithms of being a simple general model. Seems like I know very little about anything that's cryptography or theoretical computer science or anything along those lines. Me too, Lucas. I'd like to know more about it, but I don't. In theory, you do cryptography research. Or in research, you do cryptography theory. Suppose A is an F, V is an V, and AV equals 0. Prove that A equals 0 or V equals 0. Inclusive or. In reality, you just fart. It's pretty cool too. I'd rather ignore my lack of knowledge and learn other stuff. Yeah, I mean, you only have so much time. You should spend it learning the stuff that you like. Okay, so we do know from previous propositions that a times 0 equals 0, and 0 times v equals 0. These are two facts that we can work with. Sounds good, Thorfinn. See ya. You find cryptography very compelling. Is it at the intersection of so many fascinating / relevant topics? It does have a weird way of pulling in other types of math. For sure. So I guess we probably want to start by supposing a is not 0, and then we suppose v is not 0. My proof is wrong. Really? When you distribute a times 0 plus bv, you assume you have a 0. Oh my god. You're right. It's just annoying. I don't believe in anything, especially not myself. You can't answer means of communicate, whatever that means. Um, oh, I mean, yeah, Max, but I assume that like we could show it has to be true using the other axioms. Like, if there's something to be learned from doing this, then let's do it. Well, it's like I'm imagining if we chop that axiom off, can we make it follow from the other axioms? How would you know what it means to know something in a mathematical context? I feel like that's a philosophy question, Leo. What does it mean to know something? You usually see it as an axiom. Okay. I don't know. I could just move on and go back to doing number 2 here, but I don't know. There are multiple answers in cryptography / information theory for what it means to know something. You're a human being unlike any of those crazy animals. A Platonist, a formless intuitionist, or something else. Essential axioms, the real thing would be to come up with some weird counterexample. Okay. The vector space axiom is also an axiom in the more advanced concept of modules, which are basically vector spaces. Okay. I mean, I'm willing to just move on from it then. Oops. Put my mic. Do I have that 2 factorial equals 0 in my field? I don't think so. But Dawn factorial equals 0. I can go with that. The module is a vector space, except instead of a field, you have some ring. You don't need to worry about it. Yeah, yeah. I'm just worried about this proof here. I know I know there's a bunch of weird terms. Like, I don't know if it's related to this, like bundles and stuff like that too. Bunch of vector spaces glued together like a boy band. How many boy bands are glued together? More soon. Leo's gonna show up to concerts with a bottle of Gorilla Glue. Is this a grade 2 question, Atishe? If a second grader could do this question, I want to see that second grader. Just enough those guys are pretty thin. So if we're supposing A is not 0, I assume this would come in handy somewhere. Have I tried addition? Never. Once in my life. F is a field, V is a vector space. I would never do multiplication either. Um, I refuse, Leo. I refuse. You'd recommend multiplication. I mean, do I take... So we know that AV equals 0. Do we multiply each side by 0 or something stupid like that? Like the vector 0? Well, what does it mean to multiply two vectors? That doesn't make sense, right? We haven't defined that? Hmm. Yeah, we only have scalar multiplication. Uh, yeah. Scalar, I hardly know her. Simply put, two-dimensionless vectors are at origin in a two-dimensional grid field. I appreciate that's basically the plan. Um, God, I hate proofs. Um, proofs are no. This is I'm doing it because I should be better at it than I am. I've never once thought a proof is fun though. I don't think I have at least. Let's all love proofs. Oh, ha. Okay, Atishe. I think you're on to something there. Where am I? What's we know that scalar a has a multiplicative inverse. Hopefully we're allowed to say anything times 0 is 0, scalar. Okay, there we go. That's it. Leo lectures poops. You saw someone talk about him pontificating. Oh, I mean, yeah. This means like talking really fancily, I guess. Because Axel proved it earlier? Okay. J. Cummings Proofs book? Let's see. J. Cummings Proofs. Images. Is this some proof about tiling? There's a... Is this this little like Tetris piece does not tile the plane? Is that what this proof is? It doesn't. Yeah, yeah. My bad. That was obviously meant for Leo. Can always tile a square if you remove one square. Well, I feel like that's kind of cheating. Are like, you can tile it if you remove a piece of it? That's probably useful for something. You see the square you move is really big. True. Problem is that the word is in completely wrong contextually. Sentence. Oh, yeah. That's even worse when it's not used correctly. Still bad, Dessen. 2 to the n by 2 to the n square. Oh, yeah, that makes sense. Probably. I'm just saying that makes sense because you said it, I think. I haven't actually worked anything out for myself. Hey, Fembucks. Unless you were lurking, you missed out on Zach doing the E&M midterm. I was pontificating all over the place. Holy shit. Also, that's not a noun, that's a verb. That's the first proof you're like, oh, that's cool. I don't know. I there has to be a proof that I think is cool somewhere, or that I thought that I've seen already and I thought was cool, but none are coming to mind. Oh yeah, that's stupid, Lucas. Oh, you couldn't watch it. That sucks. Well, that wasn't a real proof, Leo. Or wait, do you mean the proof or the proof that's not true? I don't know. Uh, been looking for jobs. Gets you a lot of squares. Okay, okay. Found nice jobs in New York, most over 80K. Need data science, ML, or math modeling. Right. I remember that now, Leo. That's basically the type of job that I've been applying to, Dessen. If you manage to get one, my hat's off to you. I hate it because you were there. Sure, Dessen. I probably won't be able to do it, but we can at least read it and be confused. Some cool person proof. Some other cool proofs include the Fibonacci equation by generating functions, and Tychonoff by ultrafilters. Ultrafilters. Generating functions, those can be pretty neat. Ultrafilter. Okay, if v is not 0, what do we do now? Is that Jose Lito? Can I recreate the natural numbers with null sets, but not exactly how? Actually, I have not gone through that for myself. Um, it might be simple enough that I can figure it out. Off the bat here. Let's see if we can... Hey, von Neumann ordinal, shout out. So I know there's different ways to do it. I think this is the way that I might have seen. I don't know. These are the best. See, let 0 equal the empty set, and n plus 1 the successor function be the previous set unioned with itself. Well, okay. Or no, the next. Wait, what? I'll look at it after this, Dessen. Alright, so now that we've defined 0, we can use it in this definition here. I guess. To define 1. I have it open here. Well, I'll have to get to this too. Definition property, n is a set with n elements. The first few numbers counted this way are 0 is just the empty set. 1 is the set containing the empty set. 2 is the set containing the empty set and the set containing the empty set. Okay. You might have seen a different way of doing this. I'm just going to assume your name is pronounced Jose Lito, unless you correct me. But I think they're, well, actually, I bet it's on this page. No, it's not on this page. It is that. Oh, okay. Thank you. Um, there are multiple ways of doing this. Pronounce Leo lectures. Yeah. Gonna go to drop a PDF in Discord on my iPad earlier today, and Penzar told me you had activated Unk mode. You don't understand the sum. Uh, like this sum here, or do you mean like when we're unioning on the right side here, like 2 + 3? Okay. Uh, that's a good question. I would guess you could translate it as like repeatedly applying the successor function. So like you could do 2 and then uh like this is like something like that, or equivalently. That's my guess for how you can do it. It is a lot of suck. Addition. When two or more disjoint collections are combined into a single collection, number of objects in the single collection. I mean, okay, yeah, let's go down here. Math hacking is known strictly as set theory these days. I don't know what order theory is, TT. Box arithmetic? I have not heard of that. Sets of the piano. Axioms. 10 years before. I don't know. I don't know how to define sums now. Now, just review the cardinalities of finite sets. It is appropriate to define their sums as follows. Let n of s be the cardinality of a set S. Take two disjoint sets A and B. Well, that doesn't... They're not disjoint, though, with the definition of... Or, like, with the natural number construction that we had before. This is not what I'm looking for? Okay, yeah. The second paragraph is? Oh. Let's see if it's on this page. This is like what Ultra Products is saying. So you start with a plus 0 equals a. That might be an axiom? Maybe? A plus s of b is equal to s of a plus b. What is s? Or is that s times b? Or I actually don't know what s is. A plus 1 is equal to a plus s. Oh, success. Ah, hot. Thank you. a plus 1 is equal to a plus successor of 0, which is equal to the successor of a plus 0, which is equal to the successor of a. Okay. A plus 2 is equal to a plus successor of 1, which is successor of a plus 1, which is a successor of a. Oh, hey, so I got it right. I just kind of skipped over this what you start with. Yeah, I guess the moral of the story is you just keep using the successor function repeatedly. To prove commutativity of addition, first prove 0 plus b equals b and s of a plus b equals s of a plus b, each by induction on b. Using both results, prove a plus b equals b plus a by induction on b. The structure n with addition is a commutative monoid with identity element 0. You can tell someone else wrote this part of the paragraph. This is really abrupt. N plus is also a cancellative magma and thus embeddable in a group. Yeah, sure. The smallest group embedding n is the integers. That's true, ultra products. And this is stuff that I want to learn someday too. I believe that they're essential. I just don't understand them. What time is it at my palace? Well, my palace is so large, it has its own time zone. That time zone happens to be perfectly aligned with West Coast US, though. It's 3:39 in the afternoon. Do you like a citation is needed? Yeah, just send them a proof. The caveman numbers used to be magmas. I've seen the word magma before used in math. I don't know what it means. I'm sure I looked at the definition and I didn't understand it. Wait, this is a linear algebra question, Dustin? Oh, awesome. I'm glad this helped, Jose Lito. Yeah, thank you for the question. Yeah, I don't know how to do this. I don't really want to know how to do this, Destin. I'm sorry. It is linear and it is algebra. I guess it's true. This is a linear combination of group elements. Oh yeah, and Jose Lito, if you're interested in math streams in general, I have this list of people I can like recommend. 2 is an element of 3. True. You basically do Gaussian elimination over Z. Huh. I guess that makes sense. Well, not really, but I could do that. Don't sub-delete lectures. When a 3v3, then Gaussian eliminate. I mean, I don't want to do Gaussian elimination just for fun, though. Like, I don't know why it would be that. I can put in Dwarf Apple just to see what the answer is from the Gaussian elimination. But, like, I don't want to do Gaussian elimination just for fun and not understand any other part of the problem. Yeah, I think let's look at Leo's blog post. That's true. Yeah, we Okay, okay, this isn't that long. I saw Galois. Yeah, nothing about the golden ratio. Wait, part 1? Okay, fine. Also, a while back I saw a list of almost integers, numbers which coincidentally are almost integral. E to the pi minus pi is almost 20. Wow. They're both... Yeah, no, I thought it was weird. I thought it was so funny to have a part 1, but it was also yet another. This list first started by noting that powers of the golden ratio get closer and closer to being integral. I don't even know that. Integral. That's kind of fucky. Okay. The odd powers of rho are a little greater than an integer. The even powers are a little lesser than an integer. Thank you for the follow, Jose Lito. Robner basis? I'm okay. You immediately clocked y. If you let rho bar, oh yeah, be the conjugate. Oh, sure. Oh, yeah. Basic fact from algebraic number theory. You can see that the term rho bar n, or wait, phi, sorry. It's Leo's. Approaches 0 exponentially fast. Alternates between being negative and positive. For L, and we have that rho to the n is equal to L sub n minus 1 over phi to the n. For ln a sequence of integers. Okay. It's all about ants. Given a monic irreducible integer polynomial, the sum of the kth powers of its roots is always an integer. Okay, yes. That's, and this thing up here with phi is an example of that. It's basically that like well actually that's kind of the kth powers part is unexpected. Like if it's just the first power, it's that the radicals always come in conjugate pairs. And I guess even if you take powers of that, the distribution works out so that they still cancel. Reason more than the same as a complex number is real if and only if z is equal to bar z. Okay. Conjugation, commuting with multiplication, and addition. Okay. Oh my god. I'm tired. Roots of polynomials of this form are called algebraic integers. Oh, no. Make a new word. Don't reuse integer. Root 2 is my favorite integer. Ugh. Wait, 1/2 is not... You can't make 1/2 to be the root of a polynomial? Harmonic irreducible integer polynomial? Oh my god. We even call them rings of integers when you mean rings of algebraic integers. Oh my god. Sure that 1/2 is not an algebraic integer. Well, the thing that's going to break is the integer coefficients, I assume. Yeah, this is a blog post that Leo wrote. Okay, can we actually figure that out if we stop sucking? um, suppose 1/2 is a root of a, what was the list of words? Monic, irreducible, integer. That's not how you spell integer. It doesn't matter? Okay. Well, I thought, like, okay, so it's irreducible over algebraic integers. So it's like, my thought was that, at first I thought, like, you can only be quadratic or linear to be irreducible, right? But I assume we can have higher degree. Coefficients are normal integers. Okay. Right, x squared minus 2. Algebraic integer coefficients. But don't do that, you'd be overcomplicating it. Okay. I wanted to basically do something like this. Could there be a coefficient now? I guess no, there can't be. Wait, how does this look? These are new coefficients, I think, is the issue. The key problem is that monic leading term. I don't actually know what monic means. Monic. The leading coefficient is 1? Oh. Okay. Ideal class group in computer for square root z square root minus d? I don't even know. Monic equals mono equals uno. Well, yeah, I know that, but where does the one go? Apparently goes in the leading coefficient. You know what I have? Boom, uno. I feel like I can't, I don't know how to make progress if I can't say that this is degree 1 or 2. Because, like, it can't be, there is chart permute for degree 2. Okay. If it is degree 2, we would need to find something like x squared plus a1x plus a0 equal to x minus a half times x plus any other number b. I don't know if it's even what I want, but b minus a half x minus b over 2. You are the unsolved problem? Maybe you are, TT. It's an even simpler trick. Like, I can imagine that. Well, I don't know. You have no blind spots. Prove you right. um, do a weird induction over the regular integers. Much harder than the other way. I am not against simple tricks that are too slick that make me feel dumb. I it shouldn't be anything that hard. I thought it would pop out more naturally if I did this, but apparently not. What happens if you just plug 1/2 on the left side? What does happen? Uh, we need to show that there is no a1 and a0 that are algebraic integers such that this equals 0. Multiply by 2. Regular integers, not algebraic integers, such that this equals 0. Can this be 0? Oh, well, if they're regular integers, then no. The 1/2 means we can never do that. Okay. I mean, we could have made the same argument about the 1/4 without having multiply 3 by 2. I guess that this does make it a bit like easier to see, though. Okay. Not Chris. A1 and A0 here are integers, so no. What about the degree n case? Well, let's plug and chug. I'm a plugger and chugger. Oh, maybe you multiply 3 by 2 in the last one, because it is maybe more convenient to do here. Am I a mathematical constant? I don't know, maybe. We can make a1 and a0 0, but that doesn't make the entire thing equal to 0. Is I a mathematical constant? The imaginary number I is a constant, isn't it? Why not? It's not well defined? Oh, okay, not Chris. We can't tell the difference between I and minus I. Well, one has a minus sign in front. Easily. Come on, Leo. We're ISIS. P equals NP? Okay, okay. For streamer prom? Is that a thing, Milk and Horn? Streamer prom? Hi, Milk. You're a programmer? Yep. True. Okay, so the point is, these are all integers. 1/2 is not an integer. It's called Strom. It's all over the front page. Now, I know Streamer University was a thing. I wonder if that's related. On my front page, I have League of Legends. Oh, I do see Streamer Prom. What? Is this the most antisocial prom ever? Like, it's just people... It's just the close-up. It's a funny thumbnail. Like... Are streamers going to ask each other to dance? Do you, like, hold your camera and, like, just move around? How does streamer prom work? I have many questions. There are hot tubs on the front page pretty often. Seems a good prom awkwardly chat with friends on the out. True! I do remember my prom. It kind of sucked. Okay, so that was a little detour to show that 1/2 is not an algebraic integer. Every algebraic integer has a unique minimal polynomial, the lowest degree monic polynomial which has it as a root. For the nth root of d, it's x to the n minus d, sure. xd. For phi, it's x squared minus x minus 1. What is r? Is r just any integer? Wait, is 1/3 an algebraic integer but not 1/2? That can't be true. R is the cube root of 19? Why is r the cube root of 19? Oh, but r could be more. Okay, like you know, I still don't know what r is. I guess. When you reflect a vector, Aries adding a negative scale transformation. Depends what you're reflecting it across. But if you want to reflect it across the x-axis, you would negate the y value, yeah? And vice versa. If you want to reflect it across the origin, you would negate both. In 2D space, scale is fine for reflection. Yeah, reflection is a linear transformation, so you can always express it with like with a matrix, and that's basically just a scale transform like you're doing. No worries. Reflection is linear, right? Is it always? I know reflection across like the axes like that is linear. If you do it across like something else, maybe it's not. I'm sure I could Google it. The other roots of an algebraic integers minimum polynomial are called conjugates. Root 2's unique conjugate is minus root 2. Phi's unique conjugate is minus 1 over phi. Yep. So if I see complex conjugation, you were on the right track. Yeah, this is like a... Are they called dual numbers or something? Sum of all conjugates of an algebraic integer is integral. So last fact is key to proving the lemma above. We know that phi n plus phi bar n is integral. Since the magnitude of phi bar is less than 1, it contributes exponentially little to the sum over time, right? If you compute the numbers ln equals phi n plus phi bar to the n, you may see a familiar pattern. 2, 1, 3, 4, 7. Fibonacci, but a different starting condition? Huh. For 2, how do you find an auto for q bar to q bar? I'm gonna say that's Leo's question to answer. Apparently, a reflect vector fn is r equals d minus 2d dot n times n? You don't know what n is, though. N is probably a unit vector. Like a vector with length 1. That's what I would guess. But I don't exactly know what's going on with that formula. Two D space minus 1 is rotation by 180 degrees, which will reflect about the axis only if the axis is perpendicular to the vector. And think of minus 1 scale as reflection. So reflection about the point of origin would be fine. Yeah, that's what I was thinking. Reflection over the origin. Any automorphism of a Galois extension Q, quite literally make a bunch of choices all the way up. Construction is co-op all the way through these bigger Galois extensions. Okay. Oh yeah. Well, yeah, if you're bouncing a ball off of a wall, you might only want to reverse one of the directions. If like you throw a ball against a wall and it arcs like that, and then it suddenly bounces off. I guess it might be more like that. Like here, you would only reverse the x direction, but not the y. Like, you reverse the direction that is normal to the wall, or like perpendicular, or like the component that's perpendicular to the wall. That's how you like generally do this, I think. Yeah, and so that's where like you can use a dot product. Because if the wall is angled, then you need to do something a little bit. You need to like an actual dot product. Um, yeah, but for a simple case like just a vertical wall, you can just figure out the end result just like intuitively. But yeah. TT, I don't know what you're talking about. Meeting so it takes a bit to respond, which means I personally hate you. Got it, got it. Can you add a redeem to make you do push-ups or other physical activity? I could. That could be fun. Calculate this doo-doo. Your doo-doo. Doo-doo equals skirtle. That's my calculation. Yeah, I don't know, like, I have to figure out what a good, like, thing would be. Like, 10 push-ups for 10,000 points? Is that too much? Too little? I don't know. You have 90k points and a workout plan? And so bad. What? Skirtle equals doo-doo is a great equation. Your empathy will help someone out of a difficult situation. Skirtle, you're not going to help shit. uh, is the velocity vector the same as the direction? Yeah, like when I say reverse a part of it, I mean reverse the velocity vector. That's okay, Skirt. All you do is scream and like ask for money. Compute collectibles for every number you do a push-up. Yeah, not Chris. It's a velocity vector you'd want to mess with. Be true to the best you know. This is your high ideal. If you do your best, you cannot do more. I guess so. I don't know. You asked me for money yesterday. Yet? Well, no, I mean, in a joking way. You said I should take a vacation, and I said you need to send me a check, and then you said no, you send me a check or something like that. Um, Menage alerts. Wait, no, not alerts. Add new custom reward. Do 10 push-ups. 10,000 channel points. You gotta shell out if you want to do push-ups. We'll say it has a 30-minute cooldown. 20k for burpees? No, burpees are too much. Okay, there's now a push-up redeem. 15k version with 5-minute cooldown? No. I mean, maybe. Not burpees. Sorry, so wait. Not Chris. You said, huh, the non-normalized vector would include the speed. Yeah, the magnitude of the velocity vector is the speed. The total speed does not change if for a collision that's, I think they call it inelastic or something, or maybe it's elastic. So like assuming it's like things are ideal, which they never are in reality, but for like a video game or something, it's fine. Normalizing gives you the magnitude. I mean, so normalizing means making the magnitude 1, but you need to find the magnitude in order to normalize. Can you infer? Yeah. And so I will do those push-ups. In a second. If your velocity has let's say like Vx is 10 and Vy is -5, the magnitude of the velocity, there's different ways of noting it, but like it's the square root of the x component squared plus the y component squared. That's the definition of magnitude. So in our example here, it's square root 100 plus 25, root 125, whatever that symbol, I guess 5 root 5. That's speed. 20k for 20 lunges so I can grow a butt. I have a great butt skirt, okay? Well, lunges are probably hard to capture on camera. Like, push-ups I can do. The universally... I mean, you're about to get proof when I do these push-ups, I guess. I'm probably gonna refund that, Dustin. I don't know how to do that. Butt came when I still had the whiteboard. Oh! I forget why the butt cam would happen. I do remember joking about giving you guys a butt cam though. Okay. 10 push-ups. Oh shoot, I have to angle the camera. Crouch cam. Okay. That was only 4? Max 3 counted? You guys are being mean. Thank you, TT. Thank you, Dr. L. Man, why do you want burpees? You weren't looking. Wait, so are you gonna do the push-ups too, Syntax? There weren't 10 factorial. Oh my god, 10 factorial push-ups. Oh shoot, I need to fix the camera. I'm gonna forget to do that. Hey, there you go. Kind of burpee where I pee over my shoulder and pat your back till you burp. There we go. We can do that, Skirt. That's not weird. Control. Oh wait, universal property. You're sick. Given two finite dimensional vector spaces V and W, tensor product of V and W is a vector space V weird times W. As outdoor gym, okay. With the multilinear map pi. Mapping the Cartesian product of V and W to the tensor product of V and W. But you already had the diagram? Well, I wasn't planning to draw it anyway because I don't understand it, so... An outdoor gym? Like, do you have to pay for that? I feel like an outdoor... And the idea of an outdoor gym sounds kind of bad. It's free? Okay. That... Oh, okay, yeah. That's fine then. Like, the type of gyms that they have at, like, parks or something. Not a padding? Fair enough. What? Oh, well, yeah. The diagram doesn't make any sense to me. I'm just gonna refund that. I don't know how to draw that. I can, like, blindly copy this text, but I can't figure out that... I don't understand this instantly. I don't know what a tensor product is. I don't know what a tensor is, besides, like, a generalization of a matrix. I was going to the gym if the gym's at home, and it only has a Stairmaster. I mean, I think a home gym is better than an actual gym, if you do everything that like, you want to with it, at least. I hate the gym. Alright, I'm refunding that. I refuse to draw. Do I have too many channel point redeems? This is kind of a long list. I kind of know bilinear maps, yeah. Just started working out, so I'll use the free gym for as long as the weather is good, or you max out the outdoors gear. Not happening. That's a good choice. Syntax, especially if you end up, like, not sticking with it. You're, like, trapped in a membership. So you want, like, a bilinear map linear, then tensor product is your friend. I thought you just, like, fixed one of the inputs to make a bilinear map linear. I don't know. So powers follow a very simple familiar recurrence relation. Be another proof that phi n becomes more integral over time, doesn't use algebraic number theory at all. Then be projection. Oh, I guess that's fair. So it's linear, but, like, yeah, never mind. And, like, the definition of a bilinear map, it's linear in each of its inputs. But you're saying there's a way to make it linear overall with a tensor product. I don't really know what that means to make it linear overall, but I'm sure there's a way to do that. If one proves this recurrence relation holds, that the solution to the recurrence is ln equals phi to the n plus phi bar to the n, computing L0 equals 2, L1 equals 1, proves every subsequent Ln is an integral. In part 2, I'll prove this fact in an elementary way, quote unquote. Won't use any knowledge past single variable calculus, so having seen a generating function before would help. Oh, he even defines monic. That's nice. For the technical action by element of Galois, Q bar minus Q on an algebraic integer in Q bar. Sure. And that's the follow-up one, I assume? Ah, go away. Wait, that's the same one. Leo, you scammed me. What a scammer.
Okay, Skirt, I got you. I hope you have really nice dreams. Okay, are you asleep yet? I'm getting bored of doing this already.
There we go. That Galois group is the most mysterious object in math? Ooh. It's intriguing. If we prove that L sub n follows, excuse you. Let me put this link in chat too, in the Twitch chat. I should probably call it soon because I'm yawning, but let's see if we can read through this first at least. If we can prove that Ln follows this recurrence relation, we can compute L0 equals 2, L1 equals 1 by hand, then we have proved that every phi n plus phi bar n is an integer. As phi bar to the n approaches 0 exponentially fast, this would conclude a proof that powers of the golden ratio get closer and closer to being integral. Distance to the nearest integer approaches 0, so let's get to it. Under Taylor's theorem, a little bit on generating functions. Taylor's theorem, a little bit on generating functions. That's just what we needed. Oh my god. Recall from calculus, if one has an infinitely differentiable function f around a neighborhood of 0, can form the Taylor series. Sure. This equality holds within a neighborhood of some radius r around 0. We may have left out of the calculus class, but it's extraordinary importance that this theorem provides a dictionary between functions and sequences. From this perspective, we call these functions generating functions. Let's look at a few examples of generating functions with their corresponding sequences. Why is 1, 1, 1 the corresponding sequence for 1 over 1 minus z? Shouldn't that... Oh, I guess because the next... Oh, okay. Okay, never mind. When will Leo get a Pulitzer? Isn't that for journalism? Or something? You know, I think Leo should get every prize out there, including like a Nobel Peace Prize. Hey, Quantum Apex. You're reporting on my ass? Oh, binary heaps. I feel like I remember learning about these somewhere. I don't remember where. Every is a lot, but most would make sense. That's very humble of you. Algebraic functions come in all shapes and sizes. Luckily for this post, algebraic functions we'll see look like the first 4. That's convenient. Now this correspondence is interesting, but you might be asking yourself, who cares? That is, what does it do for us? How does it help us? How does it help solve a problem in the post? The correspondence is deeper than just what is listed above. The correspondence allows you to turn operations on sequences into operations on functions. Then, using the algebra of functions and calculus, we can learn things about the sequences. What's my favorite piecewise function? The music just stopped, by the way. I thought it was going, but it's just my neighbors playing music really loud. I thought it was my music just being quiet. My favorite piecewise function. It's kind of simple, but my mind is going to the indicator function. I'm gonna play the song. Bob, y equals ax? Dude, it's been a minute. How have you been, Bob? Yeah, y equals ax is my favorite piecewise function. You could call it piecewise, I guess. You can split it up somewhere. It's a piecewise function that's, you know, everywhere differentiable and everywhere continuous. Doing some maxima, minima related questions, some organic chemistry too. Nice, Quantum Apex. I hope it went well. Not really that chronically online anymore. I mean, that's a good thing, Bob. I'm glad to hear that you're doing well, though. Yeah, exactly, Milk. It's a great piecewise function. Do some grad school and chilling. Ooh, cool. Yeah, so I just completed a 1-year program. So I have a master's in applied math now, and the entire thing is just like 1 year. So I graduated like 2 months ago now. I think on the dot. Thank you, thank you. Do you have like a focus in grad school? Like I assume you're going to do a thesis, right? Um, done graduated 3 more times than me. Thank you, Quantum. My 1-year PhD program? No, that'd be crazy. Yeah, that's a like my program being 1 year is really uncommon. I don't know of another 1 year applied math program or math program. It's math and comp sci cliche. I mean, that's a good combo though. I assume you're still like, I remember you preferring like pure math, right? I assume you're still like going to be in like the more like theory part of that. Square sounds interesting. You might be asking yourself, who cares? Wait, did I already read this? Yeah, I did read this. I'm on this paragraph now. Ew, pure math. Do you know famous mathematicians finishing their PhD in under 3 years? There certainly have been, right? Where like they basically have already published work without the PhD, and they get to speedrun the actual PhD. Like that sort of situation, you can do it in under 3 years. I don't know a specific name, but I'm sure that's happened. Doing something infinite chess. Cool. Ordinal mate in Omega shenanigans. That's awesome. Okay, I have to ask though, because I remember like a lot of us here in like Twitch math had a phase where we were talking a lot about infinite chess. Did you? And I think you were there for that. Is that what got you into infinite chess, or did you already know about it beforehand? Sounds good. Quantum Apex. Sleep well. You don't think you were there? Oh, okay. Never mind. Yeah, there's a streamer, Admiral Stapler. I've seen him streaming Minecraft recently, but I think he's published on Infinite Chess. I haven't seen him do a mash in a long time, but I remember, I think Ian Stuckey figured out that there's a connection between a video that a bunch of us had watched on Infinite Chess and Admiral Stapler's work. I don't remember the details though. Anyway, that's cool that you're getting into that though. Infinite Chess moves formed a group. It would embed in. I'll have to take your word for it. There are many corresponding operations. Today we'll only need two: addition and shift. What about alt or caps lock? How much do I know about ordinals? Well, I know it starts with like the natural numbers I think are like a left 0 and like the real numbers are a left 1 or something like that. And I know you can go like a left 2, left 3, and you can do like a left to the power of a left or something. And I know we use infinite chess to like give examples of those different levels of infinity. where like you have an infinite mate that, or like an infinite sequence that leads to another infinite sequence that eventually mates, or something like that. Uh, I'm drawing on a video I watched like probably 2 or 3 years ago now, but I'd say I know the bare basics of ordinals, I guess. Is it cardinals? Oh, maybe I'm wrong, Max. I thought infinite ordinals is the name that you give to that stuff, but it is also the cardinality of sets. I guess I didn't know there's a difference. Cardinals are ordinals in standard construction. Okay. Suppose you have two generating functions f of z and g of z corresponding to function sequences f sub n, g sub n respectively. The sum h of z equals f of z plus g of z is the generating function for f sub n plus g sub n. For shift, z f of z is the generating function for the sequences. The sequence s sub n equals f sub n minus 1. I can imagine why it's a shift, yeah. For if you're talking about like a Taylor series, because it shifts your powers of z. Oh yeah. Because I've this type of thing comes up for differential equations too. Well, sorry, not for differential equations. If you have, because I learned about this with like probability generating functions. You can get differential equations out of them, and this kind of like z f of z thing comes up there too. What are archbishops? I don't know. For any countable ordinal, you can construct a position that in that ordinal. If you have only finite number of pieces, it is only known for like omega 3 or something. You can maybe pursue it with your chess knowledge. Ooh. That's right. You are good at chess, aren't you? It's only known for fatty acid omega 3. Differential equations start with difference equations. There was, yeah, they pop up from difference equations. That's right. I looked back at my notebook because we use probability generating functions in my cancer modeling class, and I'm trying to remember like what we learned about in those. Now that I'm mag, am I Don Mag? Wait, what does it mean to be mag? Imagine being a GM on Infinite Chess. You might be trapped in playing a single game for the rest of the time. So back our original problem with generating functions. We have the sequence L sub n equals phi sub n plus phi bar n. What is this generating function? The table above, we already have the generating functions for s sub n equals a to the n, given by 1 over 1 minus az. Sum these together. Phi and phi bar, we get the generating function like that. That checks out. That's... Does it actually simplify like that? Or did we get that from the table? It's kind of crazy if the radicals can't cancel out. It's only in Croatian. Okay, I was like... You can do that and get that? That's... Huh, okay. Same magister. Oh, I mean, there is just the bishop in chess, but we don't call them archbishops. You have a master's, aren't you a mag? Oh no, you don't get a title for having a master's here. You get to be a magister in Croatia. That's cool. I wish maybe I should just start calling myself a magister. Skill issue. Doing a little algebra. We find this. Sure. What does this last equation say? Ignoring the 2 minus z part, which only affects the value of L0 and L1. Well, we care about that, but we get this that says L sub n is sum of its right shift by 1 and right shift by 2. Yeah. It's for n greater than or equal to 2. The 2 minus z part essentially ensures that L0 is 2 and L1 is 1. Huh. Okay. When we plug in z equals 0 or 1. The 2 sets L0 equals 2, the minus z and ZLZ sets L1 equal 1. Don't we have an L of 1 though to worry about? Oh wait, that's how you get L of 1. Okay. Sure. So we're called doctors even with a master's. Oh, that is true in some countries, right? With PhD in the US, unless you're a professor or a medical doctor, you don't go by doctor? Really, Milk? I thought you could, like... I thought being a PhD means you're always a doctor. Even if you're not a professor. And Don baits me by saying he hates me and don't like my videos. I'll call him the masturbator. Go ahead, Leo. Go like spelling... Oh my god. Vijaya Raghavan? On an exam? Yeah. Theoretically you could. You don't actually go by doctor. Huh. Oh, that's where you got that word, Bob. Okay. Do medical doctors go by doctor in day-to-day life? Those that do are pretentious as the academic real doctors who do the same. I mean, I would think not. But I don't like if I see a professor just like out in the wild, I would still call them doctor. I'm kind of like formal like that though. Like well, my professors like who I've known from my undergrad, so like nearly 10 years now, I still call her doctor every time I email her because I just feel like that's a respect thing. I don't know. Stuki, I mean, I would think that Stuki is a doctor because Stuki does have a PhD. And that I always thought was good enough. Yeah, that would be weird, Dr. Cook. I was wondering what you were doing, Bob. You know, you can hit your keyboard as much as you want. There's a lovely Fourier analysis proof that PV numbers have measure 0 as a subset of the reals. Oh, I was about to ask what a PV number is, but I figured it out. Yeah. Leo, could you please spell it out for me? Why is it, or is this unique aspect of the golden ratio? Long afterward on those types of numbers. How? I don't know. That's some. I don't think everything needs to be in a diagram. I do like diagrams in general, but I feel like I need to organically feel the the need. Is the afterword longer than the actual word? No, it's not. Okay. Yeah, Bob, I think that's a good take. Like, it depends on the context. Like, if you're talking to someone because you want to ask about their expertise in their subject, you should probably call them doctor. But if you're just having a normal conversation, then probably not. But yeah, I guess like Milk, I'm not saying like people actually go by doctor all the time, but they have earned the right to go by doctor if they wanted to. Even if they would be kind of pretentious if they did in every single case. Minesweeper? It's already been 30 minutes? Oh my god. Okay. We'll do the Minesweeper first. Oh, come on, this. Hmm. I could go faster, but it's kind of making me cross-eyed for some reason. Okay. I know, it's because of Bob, it's literally just like a month ago I learned from people in chat that I always thought the flags were just aesthetic. I didn't know they had an actual purpose in Minesweeper with courting. So I literally just learned a month ago that courting is even a thing. I've been like doing Minesweeper just on my phone for like probably 10 years at least, and I just never knew that you could court. I would be helpful in Normandy or Iwo Jima for sweeping mines. I don't think this is very I don't think this prepares you for real life minesweeping. Getting in the set of numbers such that the distribution theta to the n is uniform in 0, 1. Fractional. Oh. Okay, 10 more push-ups. No hour sweeping. I might need to up the cooldown on that. Otherwise, I'm gonna get, even buffered than I already am. Those were harder than the first 10. Thank you, Cook. Yeah, exactly, Leo. I'm already so buff. Okay. Oh, yeah. Um, also, I do have chess and chess.com accounts. I have played against people on stream before. I just honestly I find chess in general really frustrating. Yeah, I mostly wait. Why do I have a question mark? Is it because I haven't played in a while? I usually play like 5+3 or something. But yeah, this is like maybe 11 or 1200 on chess.com. It'd be cool. I know that Dr. Gold does stuff like that. To get like a chess tournament going. Oh, true. Yeah, yeah. That makes sense. Okay. So this is not unique to the golden ratio. Who's this? I mean, Bob is up there, I think. Lucas is apparently good too. Or I played Lucas. I forget what his elo is. I'm sure there's other good chess players. I can think of someone who is like ridiculously good, but he hasn't been around in like years. You're commanding 100 elo? That's a lot of elo, Leo. You should name yourself to elo lectures. Druha. It was like over 2,000 on chess.com, I want to say. When I mean like ridiculously strong. Is there a way to like add people? Like oops. I'm not to play this sometime, Bob. Today I'm tired. I'm gonna wrap the stream up soon, but follow. There we go. Oh damn, you might be the best one, Bob. 1400chess.com. Okay, so you're a good bit better than me, Dessen. Uh, it might be. I just put it onto a radio. If you want to know the song it's playing currently, it is linked to my Discord. Hopefully that link to the playlist works for you. Correspondence chess is you play one move a day, or something like that. This playlist was generated. I made a radio playlist for the song After Dark by Mr. Kitty, which is a banger of a song. Yeah, Project Euler. I haven't done Project Euler in a minute either. But there is hopefully going to be another coding competition in the near future, and we have used Project Euler for that before, like a math streamer like programming competition. I've never been too into Amon Amarth. I've listened to a couple of their songs, but like metal and rap are my two favorites. My favorite like genres. I just don't play either of them often because they can be kind of polarizing. My favorite correspondence theorem in math? What is a correspondence theorem? Justin Bieber? Can you make a problem again? I can mention that. We were gonna do some like freaking we were debating between like Project Euler, Advent of Code, and UVA. And but like as long as we like have a way to check the solution, that's probably fine. I can send a DM in the group DM that we have for the coding competition people that you offered. I can throw a ghost song in there though. Ghost is not that hard. It's metal, but they don't like scream, is what I mean. It's about to play in like 15 seconds. But yeah, I do like metal a lot. Why don't I go direct to dual vector space in my LADR textbook? That's where the fun begins. Where even is it? Duality? Because I gotta start with the basics. If I'm struggling with like the proofs in 1B, then I don't want to go too fast. I'm improperly flirting with my ghoul friend. That could be fun, Fembox. Tokyo Ghoul, no. Hey, Roxra. Yeah, I would do pretty terrible on the magnetism part, I think. I when Zach was doing it today, I followed along and I put my own answers to the multiple choice questions. I think I did well. I might have missed one or two of them, but I think I got almost all of them. Part 3 of this blog post. Ooh. Coxma. It's a funny name. I'm trying to talk a little bit less so I don't talk over Ghost. Get my cocks in your face. That makes sense. That was like the essential property for the golden ratio to have this property. I know it'd be breaking the rules of like being an exam, Fembox, but it could be fun to like just tag team the exam one day. Whose numbers also have an elementary proof. Okay. You are? Okay. And by one of these days, it can be like, wait, how did 2 ghost songs get in here? What? I don't even know this ghost song. Somehow a second ghost song snuck its way into my queue. I guess I'll let it ride. Yeah, you know your ghost. Read the quote on page 19. Oh, okay, Cook. Surprise attack from the YouTube. Ooh. Welcome to the other side. That's a pursuing snacks. What is today, Thursday? I have an obligation on like Tuesday of next week. I think it's the only thing that I have though. I want to say it's Tuesday. I'm in a constant of pursuing snacks. Yeah, that I think that could be a fun stream, Fembox, if we try, I guess like midterm 2 together. Doubtless the very strongest attraction, the greatest fascination goes with the new world of Abelian algebraic geometry. I probably wouldn't study that much, but I would at least like skim back through the Purcell book. Doubtless the very strongest attraction, the greatest fascination goes with the new world of Abelian algebraic geometry. It may seem strange that instead I am indulging in this lengthy digression on homotopical algebra, which is almost wholly irrelevant, I feel, for the Galois-Teichmuller theory. The reason is surely an inner reluctance and unreadiness to embark upon a long-term voyage, well knowing that it's so enticing that I may well be caught in this game for a number of years, not doing anything else day and night than making love with mathematics and maybe sleeping and eating now and then. Making love with mathematics. I was wondering where this quote was going. Abelian algebraic geometry has not worked out, so it's the right choice not to make love to it. My name is Alex and I fucked a stack. Hell yeah, Fenbox. Okay. This would be cool. You haven't done real math in like a year. What in the world am I reading? I don't know most of these words either. Abelian, I guess not commutative. Algebraic geometry. Geometry that's algebraic, clearly. No, I don't know most of these words. Or most of those like math words. Not really, Dustin. I don't know what a stack is, and I'm sure if I looked at the Wikipedia page, I would have 5 more words to learn at least 2, and each of those 5 words would have another 5 words that I'd have to learn. Go back to calling homological algebra homotopical algebra. Sure. Suppose you have a PV number alpha 1. How do you have multiple conjugates? Wait. Okay. This is back to the playlist. The whole site. True, Max. You make a strong point. We get even conjugate here. Generally don't recommend definition reading, although it is a popular pastime of online math enthusiasts. Yeah, that's why I didn't. That's why I'm not going to bother looking up what a stack is, because I know I'm not going to get it. in the Bay Area, it's a good song. Calculate the initial n values, show they are integers. For k equals 0. That's my brain is kind of fading. I don't know if I'm really following this now. I can see broadly how this mirrors what we just did, but wait, at the very end, they might work too well. They should let you skip all this generating function business as well. Joke's on you, this is entirely for nothing. No, I'm just kidding. Don't expect a part 3 explaining Newton's identities. Instead, expect a part 3 explaining Coxmouth theorem or whatever it is. Using me to double check typos. I did find one. Absolute banger of a book. Which one is that? Geometry of Physics by Frankel. It's already fixed? Oh, okay. He said follow instead of follows. I don't remember where it was, though. Or is that in the first one? I don't know. top. I don't remember. I don't. Oh wait, Control F. Haha. I'm smart. Eventually. Geometry of Physics, Frankel. I think it's just gonna have like a purchasing thing. I did just yeah, it's true, Max. It got erased from my memory too. Wait, Berkeley. Is that where you went, Cook? I can't remember. Unless you don't want to say. Dimension forms before I read it. If this had any geometry. Happened. But no, he also went somewhere in the Bay Area. That's a metal photo. It's fine, Dr. Cook, never mind. God, imagine valuing your privacy. Never be me. I did just look at it. So I was just like kind of randomly looking through physics books last night to see if there's one that caught my eye. There was one about variational physics that looked kind of cool. Like I because like learning calculus variations was cool, but I still don't know how you really like come up with the Lagrangians and Hamiltonians. Like I guess it's like k minus v, but there's got to be like more to like setting it up. Attach TV for mod application. Oh. God, I feel like my alerts have gotten louder. I don't know why. I turned that one down mid alert. Jose Lito, thank you so much for the prime. That's very kind of you. I really appreciate that. Thank you, thank you. It's dedicated to Profbot. He also has nice books on algebraic topology. Oh, cool. Overview preview is amazing. Kind of a black hole trap. Just skip it and move on. Okay. Creation principal mechanics by I don't know how you pronounce that. Yeah, I mean, I'm probably not going to actually study it, but I do want to. There's other things that I probably should study sooner. I will write this one down though, if I have time. Sometime in the future. YouTube video starts from Matrix, goes all the way to Rimani, and I think you linked that before, Dessen, and I got really lost. That's one I'm thinking of at least. This book looks really advanced. Hey, topology. Oh my god. The first half or so is not so bad. This is a lot of this is new stuff. Like, this is pretty much all new stuff for me. It's amazing. This is a lot of stuff for 300 pages too. Like, this looks really dense. It's late 1800s, so not really. I think I would get my ass beat by this book. Fiber bundles. Oh, we got groups in here. Hey, there's the Clifford algebra. The tensorial nature of Lagrange's equations. Hey, someone made a joke about churn earlier. I think it was Arad. Now I understand it. You can talk about Kirchhoff's laws in terms of this weird stuff. I've done math Bob post and rail. I should get to that. Vector fields and flows, row dropping bars. Show differential topology, going differential geometry. If you churn on my Simons till I form. Otherwise, between getting to the point, still explaining things a bit. The examples help keep things motivated, so we're in through the second half. I mean, it looks sick. Like, this would be, like, I would love to understand all of the math that goes into this, and the physics, but this is, like, all this is new stuff for me that I haven't learned. It's really fucking annoying that I can have a master's in applied math and still not know like any of these words. I feel like when going through the table of contents, there's just too much stuff out there to learn. Yeah, Leo. But then, like, there's people like Dr. Cook, who I think does know a lot of stuff in this book. Or some like Fizbas too will like just drop like bits of knowledge about completely like different parts of math and physics. Same $10. Because aspirational, that 40% is like, that's way better than me. I feel like I have epsilon percent. For education, differential geometry, which along the way you learn some algebraic topology, differential topology, some Lie theory, showing how so much structure is witnessed on the topological level. Even cohomology and algebraic geometry is rather topological. I wouldn't know. Oh no. Oh, yeah, okay. These subscripts and superscripts are giving me PTSD from the general relativity studying that Fembox and I were doing. God, that was such a nightmare. And this looks even worse. Contraction, the tensor is giving birth? I think so. That's why they're so tense, probably. I don't know why I'm still scrolling through this. This is a whole mess of shit. I don't know what's happening there. One of project I thought would be good to do with AI involving flattenings of tensors, email back a couple of facts that pretty neatly showed my idea was bad. That sucks. I mean, it's good to know before you pursue it further. But I'm sure that felt like humbling. Oh, dude, have you seen a fancier E or B? What's the flattening of tensors in derived? I don't know. I already forgot where it was. Hit him with that math cal. Exactly. Very different from flatness of derived functors. Okay. So Metal Band's logos took inspiration. True. Trying to think. I only have one Metal Band t-shirt in my closet. It doesn't quite look like that though, but I definitely know what you're talking about. Remember QFT books have some wonky notation like this. Double italicized somehow? Ooh. What is this symbol? Is that script I? Uppercase I or something? With an arm? Is it a Greek letter? I don't know. Lorentz force. I don't know. It's an F? It kind of looks like an F. I can see that. I don't know. It's script F. Okay. That's the fuckiest script F I've ever seen. Yeah, I'm glad you're on my side, Leo. Fuck, this is too hard for me. Yeah, I should probably stop scrolling through this because I don't I'm not gonna I'm not gaining anything by doing this, but it's kind of fun to look at all the weird symbols. Press F for that F. True. Hey, there's no need to yell integral, okay? You do think advanced math books are more hard than more basic math books, but only marginally. Most of the difficulty is prior knowledge going into it. Hmm. I don't know. At least and think about like my math experience. I feel like it's kind of like building a skyscraper, where like the higher up you go, the harder it gets to build. I guess I imagine that's true. Like things get more wobbly. If you try to understand every single detail, of course it's hard. Yeah, we both have to immediately stop everything else we're doing in life and study physics. That will be great, Fembox. We just need to find some rich person to fund us. It does get harder, not necessarily a lot harder. I guess. I feel like you're saying if you study it enough, math isn't that hard, and I guess that's true. I don't know. Oh, I hate this T. I guess I assume that's a script T, but that's a stupid script T. I feel like this T is in the personal space of the superscript. Any rich, yeah, any rich people willing to give us free money. Showing humor and goodwill for my fellow man. So to GoFundMe, yeah, that'd be great. The more advanced slash build on stuff, math is not so much harder. Sort of. I'm poor in humor and hate most. I'm thinking of like The jump from like ODEs to PDEs, for example, you can bridge that gap because of stuff like the Fourier and Laplace transform. Like, it's not like completely like new, but it is really different. The ideas are repeated in math, though, so I think advanced math is not so creative. I guess I wouldn't know. Max, you know, that helps a little bit. Every coffee bean counts. I think it's unfortunate almost all of especially pure math education. God damn it, I was just thinking I should end the stream before the 30 minutes comes back up. I didn't want to say anything. Okay. Preparation scaffolding for setting up to learn real problem slash theory. Most people never get there, they only learn the scaffolding. That's true, Leo, I think. A lot of math education is aimless, especially for pure math subjects. Okay. God, 30 push-ups in a day? Oh. Ah. This is gonna be huge after all those push-ups. True. You use more math class to go over solid theory. Doesn't need all that scaffolding. I mean, so Leo, that's another reason for you to check out Zach / E to the 2i pi on Twitch. He just, like, I say recently, but it was maybe like a year ago now. Got a PhD in like math education / real analysis. And he loves talking about like it's like his philosophy for teaching and the issues that are currently present in like math education. I need some water. Okay. If we didn't push-ups a lot, maybe you can get money from push-up competitions. Ooh, wait, what's the world record for number of push-ups? Good force times distance. I think it's when I get the girls. That'll be the day. 10 factorial, true. Oh, like Sigma Reggie? Ask for Leo. Okay, I want to know the number. Okay, I'm bored. Did I see him? No. I didn't if you're asking me. Oh my god, that script L. Look at that thing. The script font is kind of wild. I do think I should wrap up the stream though. I feel like I'm just like not really doing anything because I'm like too tired to do math now. Lie derivative? No, it's fucky L. Okay. Yeah, I think their script font is just weird too. Chinese characters, true. Yeah, it will be really hard to learn how to draw Chinese characters. There's a lot of them though. They should, Leo. I think we should wrap things up. Blurry cam? Oh, probably because I was zooming in and out. Thank you, $5. Or like extension of that book in a way. What? Let me see what this is. I should learn Chinese. I can't even learn Spanish. Looks like a person. What? Characteristic classes. Manifolds, vector bundles. Stifle, Whitney. I don't know what any of this is. Well, there's a book recommendation apparently. Okay. I think that's it for me. I'm tired. Both my arms are tired and my brain is tired. Lots of data of vector bundles as witness in cohomology. Fair enough. Leo, good night. Thanks for being here. Both arms. Yeah, usually it's just my right arm. Plan will be for a math stream on Saturday at noon Pacific time, like normal. Double jacking it? Yep. That's how I do. But yeah, Leo, and who's here on YouTube, thank you for being here. Twitch will look for a raid.